I will go through the last class's content. And with regard to IoT protocols, we have discussed about several protocols in the last class. I think during that 2-hour time period, we have discussed a lot of details regarding the protocols. And we discussed about MQTT, HTTP, CoAP, and WebSocket protocols. So I think that during that class, we kind of, went through the facts in a kind of a fast space. So fast pace. And because of that, I think I will give a brief, overview of what we have discussed. So we have discussed about the MQTT protocol and basically the quality of service levels defined for the MQTT protocol, which makes that protocol very, reliable. And I mean, we can select the definite level of QoS level that we want to maintain for that specific application. So depending on the application, we can select what is the level of quality we want to maintain. So for MQTT protocol, we have defined 3 different levels. So in the last, in the mentoring class and the interactive class, both we discussed about the MQTT sufficiently. Then afterwards, we started discussing about the HTTP protocol, which is the hypertext transfer protocol. And that protocol is a widely used protocol for accessing web servers, right? So if you want some resource from the internet, and we want to achieve some data regarding some kind of website, then we want to use, we normally use HTTP protocol when we use the standard communication, when we use the standard communication architectures, and when we use the standard infrastructure. So HTTP is the most popular protocol used for accessing websites, information about websites, and so on. When we talk about the CoAP protocol stands for the Constraint Application Protocol. The Constraint Application Protocol is a version of protocol which is similar to HTTP protocol, but it has some it has lesser functionalities than HTTP, which makes it less complex in some scenarios. And we have a simple architecture behind CoAP protocol. So we can take it as an advantage, and we can use the CoAP protocol for applications that require less complexity and faster data transaction, right? So if we want to if you want to design an IoT network for a certain application that functions on less energy and less complexity, then we can use CoAP protocol as well. And also CoAP protocol enables you to transmit the data with less delay. However, we need to actually compare with the performance of the MQTT protocol in this case, and compare, and we have to choose the optimal protocol out of these protocols for that certain application. So when we are selecting a protocol, the most important thing is that we need to consider the application's requirements, and based on the application, we will have to choose this protocol that we are using. So another protocol that can be used for IoT scenarios will be WebSocket protocol. WebSocket protocol is a protocol that is used for applications such as real-time chatting, right? So for applications where you need transmission of data from one end to another end, and that the receiver will also keep sending information back to the sender. So if we want to keep a continuous conversation between the receiver, between the sender and the receiver, we will also use this WebSocket protocol, which is a much more, I think, advanced version than HTTP protocol. So a WebSocket protocol has different steps in establishing a stable communication. So when we compare with HTTP protocol, right? So HTTP protocol relies on request response model, right? Whereas WebSocket protocol has more features than request response. It has like about 3 main steps when it's establishing a certain communication, right? So HTTP protocol is something we discussed in the last class. So it's basically using this request response model to obtain information from a certain web server. So if a certain client is requesting some data from a web server, the client will send a request. So the client will send a request through a certain message, and that message will contain some request functions. So those request functions will compose of get, post, put, delete functions, right? So the client can, based on the client's request, this request function will be defined, and the web server will obtain this request. Based on the request, the web server will provide a suitable response. So that response will be received by the client, and after this transaction has happened, then one communication has finished. If the client want more information, the client has to send another request, and web server will respond with a suitable response. So likewise, for a certain transaction of data to happen, the client will have to send multiple requests to the web server, right? And then the web server will respond suitably, and only then the transaction of information will happen uh, based on a certain request by the client. So we discussed about how we can access a website in the last class, how we can access Amazon website, and how we can see how we can obtain the resources from the Amazon website, and then how we can get the information from the web server, right? And how we can observe the protocols being in use in the web page, right? How we can see the protocols being used. We actually we inspected that in the last class. So uh, so basically HTTP protocol we have seen in action under the website. Apart from that, HTTP is a protocol that is run over the TCP protocol, or transmission control protocol. And TCP is a protocol that is connection oriented, and therefore TCP is considered as more reliable than UDP, or user datagram protocol, right? The TCP protocol has the information about the source and the destination, and the optimal path is decided by the TCP protocol. So it is known to be more reliable than UDP. And if you want to avoid losing data, we normally use TCP protocol. So TCP protocol is used in the HTTP application layer protocol, and therefore we can assume that once we use HTTP protocol, we have some guaranteed communication from the client device up to the web server, right? We can assure that there's some optimal path or reliable path from the client to the web server once we use the HTTP protocol, right? So the default method is like that. So the request functions also we discussed in the last class. So these are actually some request functions that are basically used by the HTTP protocol, right? And these functions are actually the main functions that are used, but these are not the only functions that are in use. So there could be other, like there are many other request functions that HTTP use, right? HTTP uses more functions than this. Mainly these are the functions that are popularly used by the HTTP protocol. So the main protocol request functions are get function, right? So get is used to request data from server. And post function. Post function is used to create new data in the server, right? If we try to enter some data into the server or into the website, right? Then we use a post function. If we use put function, then that means that we are doing some updating of data in the server or in a certain website. If we use this request function delete, then we will be able to see that some removal of data is there or happening in the website, right? So get, post, put, delete functions are used to update the contents of a website and obtain data from a website. And so this HTTP client will send a certain request, and in that request, we will see the get functions and post, put, delete functions mentioned in the request URL. In the request URL, you can see these functions being used. And HTTP protocol is the is considered the basic protocol. So if we have HTTPS protocol, that means the security features are also enabled in that protocol. In the HTTPS protocol, security features are also enabled. So in most websites, we have this security feature enabled, right? So if you see this lock icon in this upper, like, in this place where I'm holding my cursor, you can see this lock icon, right? This lock icon, which shows that this website is um, secured using this HTTPS protocol, right? So security features are enabled in this website. So HTTPS protocol is the protocol that is now widely used by many web applications that has this security feature enabled, right? So HTTPS is the most popular and recommended version of web applications where the security feature is enabled, right? So if we use the HTTP protocol without the security features, what happens is that once we transmit some kind of a message, let's say a string message, which we include the word cat, we use only the HTTP protocol. That protocol will turn this, the word cat into a certain format, like certain like text, some format, which could be XML or JSON or some kind of a text format. Once you once you're converting that message contains information as it is. So if you transmit that message directly into the internet is consisted of multiple, places where the intermediate users can access that data. So whatever the data you send will be, will be accessed by the intermediate users who use the internet, right? So if you use the normal HTTP, this cat or some kind of string message will be turned into will be encoded using some encoded into a format where that format is readable by an intermediate person, right? If you convert cat into the XML format, then the word cat will still be there in that XML format, right? So if we will have certain tags and some kind of formatting in it, but the word cat or the specific information data, whatever the information, will be still retained inside this in this encoded format, in this encoded data. The encoded data, right? The encoded data will still contain the information as it is, right? The encoded data will be containing the information as it is. It will contain the raw data as it is, and it will be in the format of XML, right? There can be multiple formats of data that to which we can convert this string message. So we can encode data into the format of XML, JSON, likewise. So we have some languages that we use to encode the data into a certain type that is suitable for transmission of the data. So once we convert this data into this XML file directly without doing any kind of encryption, then the encoded data will be visible to any intermediate person who's accessing the internet from any other location in the internet. All right. So that person will be able to access this data, right? Will be able to access this data, which and also will be able to decode the data as cat. Right? So they will be able to decode the data. So in that case, like, we have to use this HTTPS protocol to ensure the security features are enabled. So what happens that in that case is that basically the cat word is converted into an unreadable format using an encryption protocol, right? Using some encryption protocols. So once we convert that word into this unreadable format, this word can only be read by the receiver, by the destination device, who has the specific key to decode this message, right? That destination person or destination device has the specific key to decode this message, and that key is shared only with the destination device. So that the whatever that encryption method, the encryption methods and the procedures we will learn in detail when we discuss about the security of IoT protocols, and when we discuss about the security in IoT networks. So we will discuss about how these keys help in encrypting the message and help in the decryption process. So anyway, what we want to do here is that send an unreadable data into the network such that intermediate devices, right? Intermediate devices in the internet, although they access the data, they won't be able to read the data and obtain some useful information from that data. That's right. So what we are sending here is not the word cat, but we are sending the word, some kind of a word which is not readable for any human who's accessing the data in an intermediate location, right? So I hope it is clear to you, right? So in this source uh, device, this device will be encrypting the data into unreadable format. That unreadable data will be sent or transmitted through the internet towards the destination. So once the destination receives that unreadable format of data, they will convert this this format of data that we have sent to the destination into a readable format using a certain private key that it has, right? A certain key that it has, and then it will convert it back to the readable, useful information format. Right? So private and public keys are used for the encryption process and the decryption process of the data, right? So so different keys are used for encryption and decryption, right? So these encryption decryption are two important steps in securing the data that we send from one device to the other device in a network. So we have to use these encryption methods to secure the data. So HTTPS protocol use two main protocols to secure the data. To secure the data, basically it uses two protocols: transport layer security protocol, TLS protocol, right? So TLS protocol actually is the most recent one. I don't know whether I have mentioned that like that in the last class. So secure sockets layer 1 is the one which was the most old version of the protocol, right? This is the old version of the protocol that is, used for security enhancement in the HTTPS protocol, right? So when we are using SSL protocol, the secure sockets layer protocol, there exists some challenges with respect to the security with the secure sockets layer protocol. And in order to address those challenges, the transport layer security protocol has been introduced recently for enhanced security features, enhanced secure performance. And TLS is the most recent protocol that is used. So, transport layer security, or TLS protocol, is the most recent protocol used for security in the HTTP protocol. And so it is mainly responsible for encrypting the data, right? So basically, anyway, TLS or SSL protocols can be used to encrypt the data and enhance the security of the data, right? So the TLS protocol is the most recent one, right? Apart from encryption, security can also be enabled through authentication methods, right? So authentication methods where you use username and password can be used to ensure the security of the data, right? So if someone is accessing certain data in a website, that person has to include their username and password, and only that person can access the data. If there are any intermediate persons who are accessing the website, if the authentication method is defined for that website or web server, right? If the authentication is applied onto that server, where the server has defined a certain username and password for each user, then intermediate users cannot access this web server without having a proper username and password, right? So therefore, using this authentication method, also we can add another security layer into this system, right? So if you have any questions up to this point, you can ask, right? Up to this point, if you have any questions, please ask. Right. So in this the next in the next section, we started discussing about the CoAP protocol, which is defined as the constraint application protocol. So the constraint application protocol is something that is used basically mainly for constraint situations, right? Where the resources in the communication environment is less. So in situations where we have devices which have less energy stored in them, or devices which cannot be recharged, right? Sometimes we are in IoT networks, we are placing sensors based embedded systems in remote areas where we cannot power them continuously, and we rely on sources such as solar energy, wind energy, hydropower, or some battery power, which is also limited, right? So we rely on limited energy, uh, and we rely on limited bandwidth. So we rely on limited bandwidth. So bandwidth means like the allocated frequency range for communication, right? So if we have lesser bandwidth, then we don't have the ability to transmit a lot of messages or a large amount of data uh, per second, right? So the data transmission is also kind of restricted, right? Data transmission also restricted up to certain extent. Therefore, we cannot send large bulks of data through the system to other devices in the network. So if we have such kind of limited resource scenarios, one of the protocols that can be used is a CoAP protocol. The CoAP protocol is based on the request response model, and it is similar to the request response model of the HTTP, right? So apart from that, it is designed for working under resource constraint scenarios, as I mentioned. So it is specifically like suitable for IoT scenarios and IoT networks, where we collect information from remote areas and we upload that information to a certain internet, to a certain network infrastructure, and then to the internet, right? Then we can, upload the data into a cloud server. So basically, when we consider like scenarios such as, scenarios such as smart agriculture scenarios, where we collect data from sensors that we place in the, remote fields, paddy fields, it could be, or any other fields, where where we depend on the sensors to give us the information frequently to a centralized place or to a certain server, right? So we rely on the sensors being active all throughout the time. So in such kind of cases, if we want to reduce the amount of energy consumption, we can enable the CoAP protocol for the application layer data transmission, right? So CoAP protocol, therefore, uh, can be used for specific scenarios with less resources. So when we talk about the CoAP protocol again, it has this request response model, right? And it has a simple mechanism where it uses this request response model basically to transmit the message, and it doesn't have much more, functions when we can compare with HTTP. Right? HTTP has more functions than CoAP, more request functions. Apart from get, the get, put, post, delete. Apart from those main request functions, HTTP has many functions, but a CoAP uses basically those 4 functions to transmit the messages. And when we consider about the MQTT protocol, when we try to compare with that, uh, the MQTT protocol with the CoAP protocol, then we can see that MQTT protocol has this additional feature where the MQTT broker is in the middle of the communication, and it helps the communication to happen in a reliable manner. However, once you have this MQTT broker, you have some more added, complexity into the communications, right? A little bit of complexity is also added to the communication, where you have to, keep transmitting messages to the broker, and the broker has to send the messages to the destination. So whereas in CoAP, basically you're sending directly the message from the source to the destination, right? So that is the difference mainly between the MQTT and CoAP. MQTT has the MQTT broker in between the source and the destination to enable reliable communication. However, it adds a little bit more complexity or cost to the communication. So I think more than complexity, it adds a little bit of cost to the communication. So we have to spend some resources on maintaining the MQTT broker and maintaining the communication link between the MQTT broker and the connected devices. So there's some added cost in the MQTT broker, and whereas in CoAP we don't have to maintain an MQTT broker. In the CoAP, however, there's a chance of losing the data that we send if we don't have like a reliable communication link with the receiving device. Then we might lose the communication link with the receiving device. That is the case, we might not be able to connect with the receiver, and we might not be able to transmit the data reliably to the end receiver. If that is the case, there's a possibility of losing the data, and therefore there is a problem or challenge in maintaining reliability in the transmissions, right? So that I think was the one that we discussed about the CoAP protocol in the last class, about CoAP being a little bit less reliable in data transmission in cases especially where we cannot maintain the communication link reliably or strongly with the receiving device, right? And if that is the case, we might not be able to send the data. So there could be some data packets that get lost in the middle, right? Right. So also, like when we talk about the kind of the negative sides or like some weaknesses related to CoAP, the CoAP doesn't know it's receiving devices exactly, right? So the CoAP is basically blind guessing the resources in the neighborhood, right? And transmitting the data to its all its neighbor devices, and the neighbor devices, if the device, if the message is directed to them, or the neighbor devices will decide if the message is intended for them, and if it is intended for them, they will receive it. If not, they will discard it. So the CoAP, in the CoAP doesn't know, I mean, exactly the receiver device, right? So it doesn't have the knowledge of receiving device in the neighborhood, and the transmitting device doesn't know the existence of receiving devices in the neighborhood, right? So also CoAP works on top of the UDP protocol, or user datagram protocol, and therefore there can be some instances where you lose the data. However, the UDP protocol enables the CoAP to ensure like save more data, or sorry, save energy, um, uh, and energy, and save the cost on establishing the communication, right? So if the CoAP uses TCP, or the transmission control protocol, CoAP might have to spend more resources on establishing the communication between the transmitting device and the receiving device, right? So if the CoAP uses UDP, the CoAP can use like connectionless protocol to transmit the data between the source device and the destination device. And in that case, that CoAP doesn't worry about establishing the optimal route from uh, from the source to the destination, right? Doesn't worry about creating the optimal route all the time, but the source will, I mean, directly send the data packet it has to all the nearby receiving devices, right? So the UDP protocol is a more like less reliable protocol when you compare with the TCP, but it's a more effective protocol in terms in terms of applications where you need to send the data as fast as possible. So when you use UDP, you can I think, ensure low latency or low delay in the communication. However, like there are other like weaknesses when compared with the protocol. CoAP, right? So you can use UDP for the communication, and it might have advantages and disadvantages as well. So CoAP, by default, the transmission or transport layer protocol will be UDP, and by using UDP, it will transmit the messages to all its nearby users, and the nearby users will receive the data properly if it is intended for them, and then they will forward it to the other devices. So up to that point, we discussed in the last class, and I think that I will discuss more about the CoAP protocol further. So we discussed about the MQTT protocol, and we discussed about the quality of service levels of the MQTT protocol. Like when we discuss about these constraint application protocols, in there also we can define some quality of service levels. So that is what I hope to discuss now in this section regarding the CoAP protocol. Right? So about the CoAP protocol, I think we have discussed basically in general how it works. Right now, we will discuss about how it, like how it works, uh, and how the request response communication happens in detail. Right? So in detail, we will discuss this part, how we can do the communication, right? So the CoAP protocol, as I said before, uses the request response model, and it sends a certain request message to the receiving device. The receiving device sends a response back to the client device. And the get message, get, put, post, delete messages can be used to send the request message, right? And that this is one of the examples that uses CoAP protocol. So it has used the get message to get some information, in here specifically the temperature information from this server, which contains the information about the temperature. So the server who has the information will respond using another message, response message, where it includes the information of the temperature in the data packet. The client will receive the information, right? So this is the basic request response communication that can happen. And when we use the CoAP protocol, we can send that information in different in different methods, right? There are basically 4 types of messages that are defined in the CoAP protocol. So the 4 types of messages that are defined are basically the confirmable message, con messages, non-confirmable message, non-message, reset message, or ACK message. Right? We will discuss about this in detail. So this is actually this is a code snippet of certain application where CoAP protocol has been used, and this code has existence of these places where they define exactly which type of message needs to be sent in different scenarios. Anyway, there's no need to understand this code. What I want to show is that in this code they have used con messages and non messages. So what are these con messages and non messages? Right. So when we consider client server communication, if we have communication that does only transmission of data in one direction, it doesn't need any acknowledgement back, then we call that non-confirmable message, right? There's no confirmation. Non-confirmable message, no confirmation. So that means it is a non-message, and it doesn't require any acknowledgement. So the client will send some data to the server. The server will receive the data. Server will not send any response back to the client, right? So if we define that a certain transaction should be a none type, then the transaction will be held in this manner, and it will not transmit back any acknowledgement from the server towards the client. So do not require any acknowledgement means the none message type. And if we want some confirmation, we have to define that message as a con message type, right? If we want to receive some acknowledgement from the server, then we define that communication as a con message type. So if we define it like that, we can obtain acknowledgement back from the server. So the client will transmit some data to the server. The server will acknowledge that it has received a certain message, And in this figure, you can see the acknowledgement has been sent back to the client. And the certain specific ID has been mentioned in the packet. Okay? So once we are sending a certain packet of data, we need to identify that data packet with a certain ID. Right? That same ID is used by the server to send the acknowledgement message and make it unique for that certain specific ID. So up to this point, if you have any questions, you can ask. Okay. Right. So we have actually, I wanted to discuss about the past paper question as well, but I will go through that in a little, in just a few minutes. So the confirmable message can be of two different types. The confirmable message can be sent and received in this manner, in this first scenario, where you have the communication from the client to the server in this manner, where you first send a message requesting some data from the server. In here, we send a message get pressure, and it is having a certain ID. So this token means the ID that we are sending the message. So once the server receives the message, the server sends information of the pressure back to the client. The pressure value is sent back to the client, and the token is also related to that certain specific GET request. When we consider the scenario number 2, so scenario number 2 is concerned about a scenario where we don't receive the acknowledgement with the data. Right? There could be some certain situations where when we request some data from the server do not have that data, and that initially the server will respond with an acknowledgement message without any data included in it. Right? And then the client will wait. Right? The client will wait for some time, and then the server will afterwards, after some time, will send the data of the pressure to the client. Right? So once the data is received like that, the client will send some acknowledgement back to the server saying that it has received the data. Right? So in here, actually, the request response or the request response method has happened in both directions. Client has requested messages from the server has responded back saying that it doesn't really have that data at that point. However, once the server has that information, the server has sent that message directly to the client as the initial message. And in order to complete the communication, the client has sent an acknowledgement back to the server. So server has sent messages and client has responded back with an acknowledgement message. So whatever the messages that has been received by a certain client from the server, the client has to send an acknowledgement regarding the received message. So so those are the kind of example scenarios that I have discussed regarding the confirmable message and how confirmable messages can happen. So when we discuss about the quality of service in the CoAP, we can maintain the quality of the communication by using the confirmable message type, right? So I don't know whether you agree. So when you have these two types of communication types, right? These two types of communication, non-confirmable message type does not give you an acknowledgement with regard to data reception, right? So non-confirmable message type do not give us information whether the server has received the information or not. However, in confirmable message, we can guarantee that the server has received our request and the server will send us some data regarding the request. So in here, when we compare these two methods, we can say that the quality of service in the confirmable message type is much more higher than this non-confirmable message type when you consider the CoAP protocol. Right? So under CoAP protocol, we have two message types basically. So once we consider these two types, basically, we can consider that this confirmable message type is much more reliable than the non-confirmable type. Right? So, right? So likewise, we can define some quality of service levels for the CoAP as well. But basically, I mean, considering the confirmable message and unconfirmable message types, right? So when you refer the internet and the sources, you might not be able to see exact words saying quality of service levels for the CoAP, but you can consider that these type of methods of sending information in the CoAP enables us to enable us to ensure the communication reliability, right? So if you are asked about quality of service, or if you have to analyze, or if you have to explain about the reliability of a communication happening, you can compare these these types of communication methods, right? Under CoAP, you can compare these types of communication. Under MQTT, you can compare the QoS levels of communication. When you compare, so when you consider the CoAP protocol, the CoAP protocol also has this one-to-one communication method, right? And many-to-one communication methods, right? So what we mean here is that, like, basically we discussed about situations where one-to-one communication happen, basically, right? Where we send a request and we receive a response. So this is one-to-one communication, right? However, there can be multiple situations where we do many-to-one communication, right? So what we mean by many-to-one is that there could be many devices that are sending data to a certain single server, right? So if we are sending data, right, if multiple devices are sending data to a single server, right, multiple client devices are sending data to a certain server, then we call this communication as many-to-one communication. Many-to-one communication. And many-to-one communication can happen in this manner, and in this situation, the server will send some separate data or separate acknowledgement messages back to each of these receiving client devices, right? So the server will send some data to each of the client devices separately. So that is basically regarding the CoAP protocol, how it functions and its main behaviors, and so on, right? So if you have any questions up to this point, please let me know, right? I will try to end the discussion on this point. However, like, I will share with you some these PowerPoint slides also in the LMS, if you need, right? If you need, I will share with you, right? So this is basically, this part is mainly focused on comparing the protocols that we had discussed against some performance metrics. Right? So I think that I will also share with you something that I have uploaded in the LMS. The LMS, I have uploaded a sample question that I have given in the last semester for the IoT module, which in which I gave a question on the IoT protocols, right? So IoT protocols. So this question is something that you can attempt now with all the content that we have covered so far, right? So this document is available in the LMS, right? If you go to LMS, you will be able to access that. Don't know whether you can see my screen. So you can go to LMS and you can go to the module page, and you can go to the week number 9. You can go to the week number 9, and in here you can go to the past paper link, and here you can see this sample paper. So in here you will be seeing a question on like the basic things that we discussed. So in here we have actually I have actually given a question on smart agriculture, and that is the reason that I have asked you to watch the video as well regarding smart agriculture. And this question you can go through whenever you have the time. You can try to attempt this question, right? And this question asks some questions regarding the sensors that are used in IoT networks. It asks about the wireless communication technologies that are used in IoT networks. Then it asks about the network layer protocols that are basically used in IoT networks. And then about the application layer protocols such as MQTT and CoAP. And it asks about which protocol is something that you prefer to use based on this application. And you need to justify the answer. Then so I'm asking you to summarize the protocols that are proposed by you under each layer, right? The protocols that you will be using under each layer, you need to specify. Finally, you need to draw a diagram of the overall IoT system, indicating all the relevant components and labeling each of the relevant components clearly in the diagram. So for the marks given for each section is also have given in here. So you can try to attempt this, and you can ask me questions if you have. Right. So if you're clear up to this point, good. Right. So if you have any questions, you can ask. Okay, so I'm sharing the attendance monitoring tool for you to see. So mark your attendance in the tool if possible.